Class 12, subject Geography, Social Science. Chapter name is Minerals and Energy Resources. Introduction of minerals. A mineral is an aggregate of two or more than two elements. It has a definite chemical composition, physical properties, and is formed by either organic or inorganic processes. They generally occur in the Earth's crust in the form of ore that contains many impurities. India is fairly rich in mineral resources, children, but their distribution is highly uneven. In India, there is a variety of rich minerals resources, and mainly minerals which are found are metamorphic and igneous rocks. The minerals resources are base for development of industries. Indian states in mineral wealth. Coal, state is Jharkhand. Bauxite, that is aluminium ore. Chromite, chromium ore. Iron ore, manganese, state is Odisha. Lead and zinc. Calcite, source of marble. Gypsum, used in fertilizers, plaster of Paris, etc. State is Rajasthan. Asbestos, state is Andhra Pradesh. Limestone mica, state is Andhra Pradesh. Diamond, copper ore, states is Madhya Pradesh. Gold, state-wise is Karnataka. Corundum, source of ruby sapphire, state is Maharashtra. Rock salt, state is Himachal Pradesh. Crude oil, state is Gujarat. Natural gas, state is Assam and Nagaland. Next comes mining cycle. Let's start from the top, available land resources, and further it goes to exploration. It takes 8 to 10 years, and next goes to environmental assessment and approval. It's ongoing stakeholder constructions, and further it goes to operation, then closure and reclamation. It takes 1 to 4 years. Monitoring, it takes 5 years, and again then it goes to available land resources. So this is the mining cycle of the minerals. Next comes composition of minerals. Composition of minerals are metallic minerals, non-metallic minerals. Under metallic minerals are ferrous, for example iron, manganese, etc. And under metallic minerals next is non-ferrous, example copper, bauxite, etc. Under non-metallic minerals are fuel minerals, example coal, petroleum, natural gas, etc. And the next is other non-metallic, examples mica, limestone, graphite, etc. Distribution of minerals in India. Sedimentary basins refers to a geographical features exhibiting subsidence and consequent infilling by sedimentation. On butyl, they are subjected to increasing pressure and begin the process of lithification. The sedimentary basins of India occupy an area of 3.14 million square kilometer, of which 3,20,000 square kilometer is in the offshore up to 200-meter isobaths. There are total 28 sedimentary basins, out of which 13 are important for hydrocarbon reserves. The next comes Himalayan belt. Geographical location, Himalayan regions. Minerals found are coal is found in sub-Himalaya eastern region. Hydrocarbons are found in Assam and Meghalaya. Natural gases are found in the foothills of Himachal Pradesh. Nickel, gold, silver, cobalt, lead, etc. are also found in this belt. Northeastern Peninsular Belt. Geographical location, The region comprising the Chota Nagpur Plateau and the Odisha Plateau, which covers the states of Jharkhand, West Bengal and Odisha. Minerals found are manganese, bauxite, copper, coal, iron ore, mica, kaolite, chromite, beryl, apatite, etc. This region accounts for the country's 93% of iron ore production and 84% of coal production. Northern Western Belt. Geographical location is Rajasthan and Gujarat along the Aravalli Range. Minerals found are mostly non-ferrous minerals, uranium, aquamarine, petroleum, mica, beryllium, gypsum and emerald. Next is Southwestern Belt. Geographical location is Karnataka, Kerala and Goa. Minerals found are garnet, iron ore, clay, monazite, sand are found in this belt. Next is Central Belt. Geographical location are Andhra Pradesh, Chhattisgarh, Madhya Pradesh and Maharashtra. Minerals found are bauxite, uranium, manganese, limestone, mica, graphite, marble, coal and gemstones. And the next is Southern Belt. Geographical location are Karnataka Plateau and Tamil Nadu. Minerals found are bauxite and ferrous minerals, that is lags in coal deposits, are found in this belt. In economic geography, the term mineral is used for any naturally occurring mineral that is mined and is of economic value. Hence, we say that India's rich mineral belt with relatively sizable quantities is confined to the old crystalline rock structures of plateaus and low hills of peninsular India. Classification of minerals. Let's begin with metallic. So under metallic are ferrous that contain iron, example iron ore, manganese, and the next is non-ferrous, for example copper, lead and tin, and the last one is precious, that is gold, platinum and silver. So children, let's begin with ferrous minerals. Ferrous minerals account for about 3/4 of the total value of the production of metallic minerals. They provide a strong base for the development of metallurgical industries. Two types of ferrous minerals are iron ore and manganese. Let's first begin with iron ore. Iron ores are the basic raw materials for iron and steel industries, children. Steel is the vital component of a country's economy. Steel is considered as the crux of modernization. Steel is environment friendly and recyclable. The finished steel production in India was found to be at 66.01 million tons in the year 2010-11. Let's see the state-wise production of iron ore in India. Odisha is 32%, Karnataka is 22%, Chhattisgarh lies in 16%, Goa 15%, Jharkhand 11% and other states compressed together is 4%. Hematite. Hematite is Fe2O3 is an iron oxide mineral. It is widespread in nature, especially in sedimentary environments. Hematite is one of the two principal iron ores. The other is magnetite, which is also an iron oxide mineral. The term hematite itself might not be familiar to everyone, but its rusty red color. Sandstones are often reddish. This is because sand grains are coated with fine-grained hematitic powder. If soil is reddish, then it is also because of hematite. Even red granite owes its color to this mineral. Iron rust itself is similarly colored, but it is mostly composed of hydrate. Next is, what is magnetite? Magnetite is a very common iron oxide, that is Fe3O4, its chemical composition, mineral that is found in igneous, metamorphic and sedimentary rocks. It is the most commonly mined ore of iron. It is also the mineral with the highest iron content, that is 72.4%. Manganese. Manganese is an important raw material for smelting of iron ore and also used for manufacturing ferroalloys. Manganese deposits are found in almost all geographical formation. However, it is mainly associated with Dharwad system. Ferroalloys are amalgamated metals with iron as the base. This process of amalgamated metals is a process of extracting metals as native gold and silver from their ores by the addition of small quantities of mercury to the stamping or grinding unit so that the resulting amalgam is caught on mercury coated copper plates from which it is then scrapped. This precious metal is in it being recovered by distilling of the mercury. These are valued for their strength, and as a result they have become pretty significant in the age of commanding giant machines. Manganese is used for this purpose and hence it is escalating importance. The given image you can see the India map of minerals deposits ferrous, and they are iron and ore fields and manganese. Let's see state-wise production of manganese ore in India, and let's begin with Orissa. Orissa is 32%, Maharashtra 26%, Madhya Pradesh 21%, Karnataka 17%, Andhra Pradesh is 3%, and other states comprising together is 1%. What are non-ferrous minerals? A non-ferrous minerals is any material that does not contain iron in appreciable amounts. Generally more expensive than ferrous minerals, non-ferrous metals are used because of desirable properties such as low weight, for example aluminium, higher conductivity, for example copper, non-magnetic property or resistance to corrosion, for example zinc. Some non-ferrous materials are also used in the iron and steel industries. For example, bauxite is used as flux for blast furnaces, while others such as wolframite, pyrolusite and chromite are used in making ferrous alloys. Copper. Copper is a well-known pinkish and softer non-ferrous base metal. It occurs as a native metal. It is both ductile and malleable. It can be made into various shapes without fracturing. It can be beaten into thin sheets. It is a soft metal. It has a high electrical and thermal conductivity. It was used prior to iron by mankind since ancient past. Hence, copper has high cultural significance. On record, this metal was known to the people of the oldest civilizations. Copper has a history of at least 10,000 years. Bauxite is a rock formed from a reddish clay material called laterite soil and is most commonly found in tropical or subtropical regions. Bauxite is primarily comprised of aluminum oxide compounds are alumina, silica, iron oxides and titanium dioxide. The given image is of bauxite rock. Let's see state-wise production of bauxite in India. Let's begin with Orissa. Orissa is 40%, Gujarat 23%, Jharkhand is 12%, Chhattisgarh is 11%, Maharashtra 10%, Tamil Nadu 2%, and other states comprised together are 2%. Next is types of energy resources. Renewable energy resources. This type of energy resource is available in unlimited amount in nature and can be renewed over relatively short period of time. These are mostly biomass based includes firewood obtained from forest, petroplants, plant, biomass, animal dung, solar energy, wind energy, geothermal, etc. These energy resources can be reproduced themselves in nature and can be harvested continuously with the help of proper planning and management. Next comes non-renewable energy resources. Non-renewable energy is available in limited quantity and they are not replenishable by nature if exhausted. These develop over a longer period. Due to continuous power, they are likely to be exhausted one day. Coal, mineral oil, nuclear power, natural gas is the examples of non-renewable energy resources. Organic sources of energy such as coal, petroleum and natural gas are known as fossil fuels. Next comes difference between, let's study about conventional sources of energy and non-conventional source of energy. Conventional sources of energy refer to traditional sources of energy like coal, natural gas, petroleum, electricity, etc. And under non-conventional source of energy is non-conventional sources of energy are recently developed sources of energy like solar, wind, tidal, geothermal, etc. And the next point is these sources of energy are non-renewable, and under non-conventional source of energy is these sources are renewable. And the next under conventional source of energy is generation of energy is expensive, and under non-conventional source of energy the point is initial cost of generation is high but cheaper in the long run. And the last point for conventional source of energy is they cause large scale pollution, and under non-conventional source of energy the point is they are eco-friendly sources of energy. Let's begin with coal. Coal is one of the important mineral which is mainly used in the generation of thermal power and smelting of iron ore. Coal occurs in the rock sequences mainly of two geological ages, namely Gondwana and tertiary deposits. So children, Gondwana was an ancient supercontinent that broke up to about 180 million years ago. The continent eventually split into land masses. Today we recognize as Africa, South Africa, Australia, Antarctica, the Indian subcontinent and the Arabian Peninsula. The southern landmasses, still carrying all those bits of pieces of the future southern hemisphere, headed southward after the split. This supercontinent was Gondwana. Children, the next is tertiary deposits. Rocks which date from tertiary geological time period Devon include ball clays, gravels and clay with flints. Ball clays are used to make a wide range of quality ceramics products in everyday use for domestic and industrial purposes, such as tableware and sanitary ware. For children, minerals found in tertiary deposits are scarce and valuable raw material of natural, national and international importance. Jharia is the largest coal field followed by Raniganj. About 70 fires have sprouted up at eastern India's Jharia coal fields, which cover more than 100 square miles and have been mined since the late 1800 centuries. The first recorded coal fire broke out in 1916 and fires have burned there ever since. It is just one of the thousands of coal fires that are burning around the world, a costly and dangerous phenomenon involving a fuel source that has helped power economic development but is under attack in the age of global warming. Children. The next comes what is petroleum. Petroleum is a naturally occurring liquid found beneath the earth's surface that can be refined into fuel. Petroleum is a fossil fuel, meaning that it has been created by the decomposition of organic matter over millions of years. Petroleum is formed when large quantities of dead organisms, primarily zooplankton and algae underneath sedimentary rock, are subjected to intense heat and pressure. Petroleum is a naturally occurring liquid found beneath the Earth's surface that can be redefined into fuel. Petroleum is used as fuel to power vehicles, heating units, and machines, as well as it can be converted into plastics and other materials. The extraction and processing of petroleum and thus its availability is a major driver of world's economy and global politics. The extraction and processing of petroleum and thus its availability is a major driver of the world's economy and geopolitics. Some of the largest companies in the world are involved in the extraction and processing of petroleum, and many other companies create products that are petroleum based, including plastics, fertilizers, automobiles, and aeroplanes. For example, asphalt, which is used to pave highways, is made from petroleum. Vehicles that drive on highways are made of materials derived from petroleum and run on fuels that are derived from petroleum. Children. Petroleum is recovered by oil drilling. After it has been recovered, it is refined and separated. It is mostly commonly refined into different types of fuels. Petroleum contains hydrocarbons of different molecular weights. In general, the denser the petroleum, the more difficult it is to process and the less valuable it is. Children, let's study about natural gas. It is often called natural gas because it's naturally occurring hydrocarbon, a particle made up of hydrogen and carbon atoms. It's colorless and consists mainly of methane, which is simplest type of hydrocarbon. Natural gas is a mixture of gases which are rich in hydrocarbons. All these gases, methane, nitrogen, carbon dioxide, etc., are naturally found in atmosphere. Natural gas reserves are deep inside the earth near other solid and liquid hydrocarbons beds like coal and crude oil. Example of natural gas is compressed natural gas, that is CNG. CNG is a fossil fuel substitute for other auto fuels such as petrol, diesel, auto, LPG, etc. CNG is made by compressing natural gas, which is mainly composed of methane or CH4. CNG is quite economical and eco-friendly than the conventional liquid auto fuels. Children, let's study about advantages of natural gas. Natural gas is a cleaner fuel. It is less harmful to the environment than coal, petrol, or diesel as it has less carbon dioxide emissions. It can be easily stored and transferred through pipelines. It is relatively more abundant than other fossil fuels, that is example coal and petroleum. It is also a safer fuel as it is lighter than air and dissipates rather than exploding. It provides instant energy, which is why it is used in oven cooking as it does not require preheating. Children, there are some few disadvantages of using natural gas also. Natural gas is a non-renewable source of energy. It means that one day we will run out of natural gas. Burning gas produces carbon dioxide gas. Burning gas can pollute the air. Like coal, much of our gases has to be imported. Children, in the given image is the map of India which shows the state-wise conventional energy resources. Next topic comes non-conventional sources of energy. Natural sources like wind, tides, solar, biomass, etc. generate energy which is known as non-conventional resources. These are pollution free and hence we can use this to produce a clean form of energy without any wastage. Solar energy. Energy produced through the sunlight is called solar energy. Under this program, solar photovoltaic cells are exposed to sunlight and in form of electricity is produced. Photovoltaic cells are those which convert sunlight energy into electricity. In year 1999 to 2000, 975 villages were illuminated through solar energy under solar thermal program. Solar energy is directly obtained. Sunlight is converted into thermal power. Solar energy is used for cooking, hot water and distillation of water, etc. Next comes wind energy. It is the one of the most important non-conventional source of energy. This type of energy can be produced by harnessing wind power. It is used for operating water pumps for irrigation purposes. Approximately 2,756 wind pumps were set up for this purpose. In 7 states, wind power operated powerhouses were installed and their installed capacity was 1000 megawatts. India has second position in wind power energy generation. The next comes tidal energy. Energy produced by exploiting the tidal waves of sea is called tidal energy. Due to the absence of cost-effective technology, this source has not yet been tapped. The next comes bioenergy. This type of energy is obtained from organic matter. Biogas. Biogas is obtained from gobar gas plant by putting cow dung into the plant. Besides producing gas, this plant converts gobar into manure. It can be used for cooking, lighting and generating of electricity. 26.5 lakh biogas plants had been established by the year 2003 and 4. They produce more than 225 lakh tons of manure. About 1,828 large community biogas plants have been established in the country. There is also a source of producing energy through plants and trees. This purpose of biomass program is to encourage afforestation for energy so that fuel for the generation of energy based on gas technique and fodder for the cattle could be obtained. 56 megawatts capacity for the generation of biomass energy has been installed. Urban waste poses a big problem for this disposal. Now it can be used for generation of power. Children in Timarpur, Delhi, a power ration of 3.75 capacity has been set up to solid waste is usually burned at special waste to energy plants that use the heat from the fire to make steam for generating electricity or heat buildings. Many large landfills also generate electricity by using the methane gas that is produced from decomposing biomass in landfills. The next comes geothermal energy. Geothermal energy is the heat that comes from the subsurface of the earth. It is contained in rocks and fluids beneath the earth's crust and can be found as far down to the earth's hot molten rock magma. To produce power from geothermal energy, wells are dug a mile deep into underground reservoirs to access the steam and water there, which can then be used to drive turbines connected to electricity generators. Uses of geothermal energy, including ground source heat pump, that is GSHP for space or district heating, generating hot water for domestic industrial use, running cold storages and greenhouse horticulture, etc. The next comes conservation of minerals. Children, it is very important to conserve minerals as it is important for industries and other uses also. So measures to conserve minerals resources are as follows. Use of minerals in a planned and sustainable manner, recycling of metals, use of alternative renewable substitutes, improvising the technology so that low-grade ores can be used profitably. The process of reducing the loss of minerals or preventing minerals is called conservation of minerals. We have to conserve minerals because it's used for industrial uses, buildings, etc. Salt is the mineral that we consume every day. Coal and petroleum are minerals. They are the source of energy. Improved technologies need to allow use of low-grade ores at low cost. Recycling of metals using scrap metals and other substitutes are steps in conserving our mineral resources for the future.